job. Okay, here we go. Now, you already did the parent, right? 0, 0, over 1, up 1, over 2, up 4. Then I think you probably mirrored the other points, right? Okay, do a 3, please. 3 right? How high? 9. Okay, there it is. Mirror it over. There it is. Okay, now you should label because you're going to have 3 graphs. You just did the parent x squared, right? Shouldn't have been a problem. Okay, now we're going to do the parent again, except what's the number in front?
2.
2. And this is called a multiplier. You're going to multiply the parent by 2. Now we're going to discover what it does. Go grab a calculator for your group. 3 or 2. Okay. We're going to plug this in our calculator. Turn it on and let's get going.
Like we really have to get a yes or done.
Look on your face, she's already really gonna ask me. Yes, you are.
Okay. 5, 4 seconds. You gotta be quiet. Now listen. 5, 4, 3, 2, 1. Stop time. Okay. Calculator's on. I hope.
3.
Yes.
I got this. I don't know if this.
I don't know what it says.
Press alpha F1-S4 to locate shortcut menus.
Where's the second? There you go.
Okay.
Y, hit it Y equals. Everybody hit Y equals. Y equals. If you have equations in there, get rid of them. Clear, clear, clear. Okay? Now, before I put the equation in 2x squared, here's what I want you to do. Hit your window button, and what I would like you to hit is this. Ready? Your x minimum. Let's go -3. Your x maximum, +3. So I'm going 3 to the left and 3 to the right. I'm closing your window. Now your y-axis, would you go minimum, 0, maximum, 10's good. We'll leave it at 10. See what I did? I closed your window this way. And then I took your y-axis, closed it up. Okay? Now, I would like you to hit y equals, and I want you to hit the parent. The parent is x squared. Here's x right here again. Here's x squared. That's the parent. You already graphed it, by the way. Come on down. Now punch in the new function. What was it? 2x squared. 2x squared. Okay, come on down. Here we go. We're ready to graph. Hit the button graph. That blue function is the parent. See it? The red function is 2x squared. Okay. Now we got to talk about this. What just happened? Okay. It did get stretched. Okay. Watch this now. The blue is your parent. Your parent goes over 1, up 1. What'd the red function do? Over 1,
Up 2.
up 2. So if the parent goes up 1, but 2x squared goes up 2, any guesses what happened?
It doubles the y.
It doubles the y. Let's see if that works. The parent, over 2, up what? 4. The 2x squared is over 2, up 8. Is 2 times 4, 8?
Yes.
Yeah, you know what? The 2 in front of the parent, all it did was double the what value?
Y value.
The y value. It doesn't double the x value, it doubles the y value. Does that make sense?
Mm-hmm.
Okay, would it work on the other side? Left 1, up 1. Left 1, up 2. Left 2, up 4. Left 2, up 8. Just double the y value and you have the graph. That's it. Does that make sense?
Mm-hmm.
That's all that happens. Now, somebody said this is a stretch, and whoever said that, you're right. How do you know it's a stretch without looking at the graph?
There's a pot or a whole number in front of
There's a whole number in front. Not necessarily.
Positive?
Well, no, that doesn't work. You're so close. Here's the deal. I want to ask this question again, but I want to ask it after he does the next part. Okay? By the way, we have to go back and graph this now, so go to your graph paper. What does 2x squared look like? Over 1, the parent goes up 1, you're going to go up twice as high. What are you going to go up to? 2. Okay? Over 2, the parent goes up 4. You're going to go up twice as high. 8. And by the way, what happens to 0, 0?
It stays.
Because if you double the y value, what's the y value at 0, 0? 0. Double 0, what do you get?
0.
Yeah, you don't go up. So you just stay there. And then I would, if I were you, I would just reflect these over the y-axis. And just go like this. And that is what? 2x squared. Okay? Well, now guess what? I don't think we need our calculator to do this one. Because if 2 in front of x squared means double the y value, what does a 1/2 in front of x squared mean?
Half of the y.
Take half of the y value. Well, that's it. Okay. Here we go. Normally the parent goes over 1, up 1. You're going to go over 1.
Up a half.
Half of 1 is a half. Okay. Normally you go over 2, up 4. Half of 4 is 2. Can you already see it's flatter? Yeah, I mean, I hope you can. Over 3, up 9.
This would be 4.5.
So it'd be 4.5. Yeah, you are here. And then I would mirror, and mirror, and mirror. Here we go.
Are we ever going to see a real life application for this stuff?
Yes, you will. You will. It comes pretty quick here, like maybe by Friday. You know, like a story problem, then you have to do some more work with it. Okay, so what is this going to be? We're going to call this 1/2 x squared, right? Just label your graphs because otherwise it's just a bunch of parabolas. We don't even know which one's which. Okay, good? So, which one's the stretch? The 2x squared or the 1/2 x squared?
2x.
The 2x squared. This is called the what? Compression. Okay. Now tell me why something stretches. Why does a parent stretch and why does a parent compress? No, can't say whole number.
Try that.
What kind of numbers, when you multiply the y value, make the y values bigger?
Slope.
2 made it bigger. 3 would make it bigger. A number's above 1. There it is. That's all it is.
Okay.
When do you stretch a parent? When you multiply by numbers bigger than 1. So hey guys, would 1.1 x squared, would that be a stretch?
Yeah.
Yes, it is. Is 0.9 x squared a stretch?
No.
No, you know what it is? It's a
Compression.
compression. So what's a compression? Anything
Lower than 1.
lower than 1, but
Above 4. Or a 0.
above 0. So between 0 and 1, that's a compression. Above 1, that's a stretch. Okay? How about the number 1?
Doesn't do anything. Just
That's the parent. 1 is the parent. Okay. Okay, done. You okay? All right. Don't need our calculators on this one either because these are what family?
after that.
After that. Go ahead, graph this one. Now, if you think you're okay with this, go ahead, try the 1/4 and then try the 3. I'll catch up with you. Okay, I think the parent took you like 20 seconds. You should be done. Right 1, up 1, right 2, up 2, right 3, up 3. Mirror it, you got it. Any questions on the parent? Okay. Now let's go with the 1/4. The 1/4 will be a what?
Compression.
Compression. It's a compression. It's going to flatten this thing up. Okay, so let's do this one in black. Here we go. Normally the parent goes right one, up one. You're gonna go right one,
Up a fourth.
up 1/4 the height. What's 1/4 of 1?
1/4.
1/4. Normally the parent goes right 2, up 2. What's a fourth of 2?
A half.
When I say a fourth, what do you do in your head?
Divided by 4.
Divide by 4. What's 2 divided by 4? 2 over 4 is 1/2. Okay. It reduces to 1/2. Okay, this one says go up 3. We'll divide 3 by 4. What do you get?
3/4.
3/4. Oh, 3/4. This is going to be the nice one right here. When you go right 4, up 4, what's a fourth of 4?
1.
There you go. Just so you know this, do you know that if I would have graphed this on my test, I would not have graphed this one, this one, this one. I would have graphed what?
Fours.
Yeah. I would have graphed numbers divisible by 4. Like this one's, the parent is up 4. 1. Here the parent's what?
Okay.
Up 8. What's a fourth of 8?
2.
Yeah, divide 8 by 4. 2. So at 8 you get 2. I probably would have done 4, 1, 8, 2. That's what I would have done. I probably wouldn't have done all these little ones. Although you can if you want. There you go. That's it. On the other side, I would have reflected 4, 1 to be negative 4, 1. I would have reflected 8, 2 to be negative 8, 2. There you go. That is called a what?
Compression.
Compression. And here's how we say it. It's a compression of factor 1/4. What's the word factor mean?
That's the number.
How it's factored out.
No. Factor is a multiplier. So what's the factor on this one? 1/4. It's a multiplier. So I would say this is a compression of 1/4. Factor 1/4. Okay, we're done. Okay, what do you think about that one?
It's going to be a stretch.
Stretch. Bigger than 1, it's got to be a stretch. So we're going to multiply all the y values by what?
2.
3. Okay, let's do it. Over 1, parent goes up 1. You're going to go over 1 3 times higher. 3, right? The parent goes over 2, up 2. You're going to go 3 times higher. Double, triple 2. 6. Parent goes over 3, up 3. You're going to triple 3. 9. There it goes. Okay, and on the back side, you just mirror this thing, right? There you go. This is what? 3
Absolute
times
value.
the absolute value of x. 3 times your parent. Good? Okay, most of your heads are shaking. Yes, yes, I got it, so I'm moving on. Until I see somebody say no, or raise your hand. Okay? All right, next. Do it again. The absolute value. Oh, look at this. I put the wrong word here. Sorry. This is not the quadratic. This is the what?
Absolute value.
Absolute value. Okay, do this. You can do that in 10 seconds. There, that was easy. Now we're going to do this one. Now that's got a negative in front of it. This is the one I want you to discover with your calculator. Let's go put in the absolute value of x. Then let's put in negative absolute value of x. What do y equals? Clear this, clear that. Hey, how do you put the absolute value in again?
Well.
Nope.
Math.
This word right here, math. Hit math. There's nowhere in here where it says absolute value, so where do you go?
Other one, number.
Go to this heading, numbers. You go to numbers. The first function is called what?
Abs.
Absolute value. Hit number 1. You get your absolute value bars. Put x inside. Not 2 x's, just 1. Okay. Uh-oh, seem to be. Okay, I got it. Now the next equation, put in negative absolute value of x. You got it? Oh, yeah, you're right. Okay, Eric, right? Eric's telling me my window's not gonna fit this. He's right. Would you guys go give me a 10 by 10 window? And can I show you a secret? You wanna see a secret? You gotta look up to see the secret. You gotta look up. Secret, if you want 10 by 10, hit the word zoom. Right here, zoom. See this number 6? What's it say?
Standard.
Zoom standard. Just hit 6, and you get a 10 by 10 window right away. You don't have to go into your window. And by the way, the parent is over there in blue. What did the negative in front of the parent do? Okay, you used the word flipped it. Actually, the mathematical word is reflected it over the
X-axis.
x-axis. That's how you would word it on your paper. A reflection over the x-axis. So negative just does one thing. It reflects it over the x-axis. So let's go back and graph it. Here we go. How do you reflect 0, 0 over the x-axis?
0, 0.
You can't. It's sitting right on the x-axis. You can't reflect it over it if it's on it. Here we go. Right 1. Instead of up 1 is down 1. Right 2. Instead of up 2, it's down 2, down 3, down 4. There it goes. Left 1, down 1, left 2, down 2, left 3, down 3. There it goes. Okay, this would be negative. Absolute value of x. Good? Done. Done. Now, in your own words, will you just tell me the two things that are happening here? There are two things.
It's being reflected and it's a stretch.
Okay, the negative says it's being reflected over the x. And it's being what?
Stretching.
Stretched. Now, if you're good at this, you just do it all in one motion. The second I knew it's reflected, I'm just going to go down instead of up. The number 4 means make all y values 4 times bigger. Okay, here we go. The normal absolute value function goes right 1, up 1, you're going to go right 1, 4 times higher.
Up 4.
Up 4, but then you got to reflect it down 4. And then of course I would just mirror it over. There it is. And then I'll do it one more time. Right 2, usually up 2. You're going to go up 4 times higher, that'd be 8. Reflect it, that'd be negative 8, wouldn't it? There it goes. There it goes. And look how quick you graph that. Negative 4, absolute value of x. Good? So what am I not making you do that I made you do on Monday? T-chart, yeah, the chart. You guys, if I made you make tables, you would hate this. And maybe you already hate this, but I guarantee you this, without making tables, this is so much better. All right, now we're done. Okay, last 3 are kind of, let's really see if you know what you're doing, okay? Those are, it's everything I have, everything I've taught you since Monday. Go, do it. I'll do the first one in 30 seconds. Hopefully in 30 seconds you're done. Negative 2x squared. You got to know what family you're dealing with. All right, 30 seconds are up. Please tell me the family you were dealing with. Quadratic, hey, right here. 2 is quadratic. Tell me what this number does. It's a stretch of 2. It's going to go up twice as fast. What does this negative do? Reflects it over the x-axis. So really, to me, you're going to double the y values and you're going to turn it upside down. That's about it. So normal parent starts at 0, 0. Now the normal parent goes right 1, up 1. You're going to go right 1.
Down 2.
Twice as high would be up 2, then reflected down 2. I would mirror it over. The normal parent goes right 2, up 4. Double 4, you get what? 8. Reflected, you get what?
Negative
-8.
8.
Then mirror it, mirror it. Is that what you got? 2x squared with a negative in front. Yes? Don, this one has a lot in it. Be careful. Give you a 30-second head start. Go. Hint, hint. Find the vertex. Where would you start this thing? This is actually yesterday's assignment with today. Okay, everybody, watch. You know, where you start is everything. So yesterday I taught you this. Inside parentheses, this means move your parabola where?
Left or right?
Right.
Left or right. Now, which way is that?
Right.
Seems backwards, it's -3, but it's forward. This is right. Whoops. This is right 3. Okay. What's this +4 in the back?
Up 4.
Up 4. So right there, now that you know it's right 3, up 4, where'd you go?
Right.
Right 3, up 4, and that's what?
Your vertex.
That's your vertex right there. That's where you start. Now the parent actually starts to get formed. Well, the parent is controlled by the multiplier. The multiplier is 1/2. Is this a stretch or a compression?
Compression.
This is a compression of 1/2. The negative does what?
Reflects it.
Upside down. It's flipped over. Okay? So here's what happens. 1/2. Right 1, up 1. No. Right 1, up 1/2, and then reflect it down 1/2. You could do that all in one motion. Right 1, down 1/2. Right? How about right 2, normally up 4. What's 1/2 of 4?
2.
2.
Down 2.
Reflected 2 down. You see it already?
Um,
Okay. Just
weird.
humor me again. Right 3, up 9. What's 1/2 of 9?
4.5.
4.5. And then flip it upside down. 4.5 would be, I think, right here. Somewhere in here. There you go. There you go. That is whatever this is. There, I got it. How would you like to make a table on that one?
Nope.
That's a lot of work. It really is.
So much.
Can we move on? Did you guys get that right? How many people actually got it right without, you can't, don't lie. You actually did it by yourself.
Yeah.
17. That's a lot. That you guys might be the winners. I don't think I had that big of a number last hour. Okay, one more. Go. Get it. Last one. Find the vertex. Okay. What's this mean right here? Right one. What's this mean right here?
Down 6.
Does everybody agree with those two directions? That, you know what? Right there is where I put my vertex. So right 1, down 6 is right about here. Okay, now I know it's a parabola or a U or a V. It's a V. It's an absolute value. Okay. Now absolute values go like this: right 1 up 1, right 2 up 2, right 3 up 3. You're gonna go, but you're gonna all your y values get what? How much greater?
3.
3 times greater. So when you do this, over 1 up 1, no,
3.
3 times greater. Over 2 up
6.
2
6.
up 6. I don't know.
Yeah, it's right on the x-axis.
Yeah, right here. Over 3 up 3 up 9. See it? And then I would, of course, I would just mirror it and mirror it and mirror it, and here we go. This is what? That one. Okay, Monday I talked to you, that's all I did. Tuesday finally gave me an assignment. Now it's Wednesday. I'm throwing everything at you. Are you okay? Because that's kind of a wicked equation. How do you graph it? That's, if I'd have given this to you on Monday, what would you have said to me?
No, thanks.
Walked out.
You would have said, huh? What do you want me to do with this? Now what do you think? Doable?
Yeah.
Doable? Alright. Well, if you think it's doable, try to do these then, okay? I have 12 grids. So I'm gonna only make you do 12. There's 16 on it. Okay?
Your choice or?
No. I'll tell you which ones not to do. 4.
Oh, come on.
6. 7, 9. Okay. Ready? Get rid of. Where we going? You do not have to graph. You do not have to graph. 12, 13, 15, 16. 12, 13, 15, 16. 12, 13, 15, 16. And 15, you're probably looking at it going,
I think we should do 15.
Yep.
14.
Get rid of 14.
Why don't you just do them all?
15 is too easy. By the way, guys, I will graph every one of these. If you want to graph every one, just for practice, do it. I mean, the answer key will be here tomorrow, okay? If you want to see if you got them all right. But the ones I just said, you don't have to graph. 12, 13, 15, 16. And then there's 2 on the back. And on the back, they drew a couple functions. Guess what you have to do?
Where's the equation?
Write the equation. Okay.
Do we have to draw in the
Please,
axis?
please go back to the front side.
Symmetry axis or
No, I know. I'm getting there. Go back to the front side. On the front side, read in the directions. Number 3, what does it say?
State the domain range.
State the domain and the range. You don't have to do it. I have not talked about domain and range, so you don't have to do it, okay? Okay, now flip it over. It says draw in the axis of symmetry. I didn't even talk about that. But, I mean, maybe you guys probably could figure that out. Right equation, yeah. I think you guys can do those two. I really do. I didn't do anything like this on the back, so maybe you don't know what they're even asking, but just try it. Okay. Bell's gonna ring in about 4 minutes. Did I give you graph paper?
No.
No. Okay.
That might be good.
Yeah.
I think I gave you 1 too many, but whatever. 1, 2.
Okay. She is really.
Calculators, if you can turn them off,
So do we have to
bring
do
them up.
the parent function? And
You do 1, 2, 3, no, 1, 2, 4, and then graph it. Just emails.
Moving, now.
Answer question.
I
Yeah, we're
can't
talking
wait.
about the ones that we don't have to grab, we still have to.
No.
It's not the end of the world.
I'm gonna do it. If you don't want to do it. I'm just saying.
Yeah, I like came in late and like I came in when it was all
Graph paper, yes. You got it?
Uh-huh.
Okay. Gotcha.
Twelve, 13.
So you think I can quiz you tomorrow on this?
Yeah.
Yeah?
Prefer if
You
you're
can,
not.
you can do it? Alright. Well then make sure you do your homework tonight. You know you can do it. Okay? Don't get
I don't
lazy
draw
on
them, I color them.
Oh, I was like, did you?
Isn't the first one
No. I cannot wait to get my tattoo. Whoa.
And back at
That's.
It's a tattoo
We
color.
got 14 calculators. Missing 13. Missing 13 calculators.
I'm gonna get back from basic. Getting an entire back piece and a puzzle cross. I'm probably gonna get my battalion across and my laws. Well, Bravo combat. Military. What is it?
That I've drawn.
Military occupied special. That's cool.
I drew that.
Oh, I was.
Yeah. One of the tattoos you're gonna get. It's a monogram, but nothing rolls. It's like a rectangle, and it folds with lines. But you can find every single letter in that monogram. So all books are is just a different combination of these letters. So every book we ever read or will read on you.
That's so cool. Actually, I never really thought about that.
And it's actually really cool.
I just have this really little.
Always.
Wait, what?
Did you, hey? Did
I didn't make any sense.
you make it easy? Oh, I'm sorry. I'm not sure.
Oh,
I think she said you're in computer lab. Are you three okay with this? You think you're okay? Alright. Molly, you're fine?
Yeah.
Anything worried? Okay. Yeah, it stretches and compressions get a little wicked. Alright, see you tomorrow. See ya.
Why am I the one?
Computer lab, I think. I think.
You're right.
Okay.
Isaiah.